Hey, my friend, do you know that nature wants you to be fat? This interview will totally surprise you. On this show, I bring back a previous guest, Dr. Richard Johnson, to talk about why nature actually wants you to be fat. He ties together so many interesting studies, a lot of which he's done himself, to bring us answers we would have never thought about before. And it helps that Dr. Johnson is one of the world's foremost experts on sugar and fructose. But we won't leave you hanging. Dr. Johnson also shares how you can beat nature, how you can outwit nature, and stay slim for life. So stay tuned for an amazing and very, very interesting episode. If you're liking the videos we're putting out on this show, please make sure to hit the subscribe button down below so you can get notified when we release new videos. Our goal on this channel is to help you look and feel younger and slow down your aging so you can look your best and live your most adventurous life. Are you interested in getting thicker, fuller, and stronger hair? Then make sure to check out fullyvital.com. I've worked with the team there to come up with a whole set of natural ingredients and techniques that you can use to really get thicker, fuller, and stronger hair in very, very quick and short amount of time. So if you want to get better hair, then make sure to check out fullyvital.com. We'll add a link down below as well. Hey, everybody. Welcome back to the Anti-Aging Hacks podcast. Today, my guest is a very special one, and we're going to talk about a topic that I think a lot of you will resonate. This is Richard J. Johnson, MD. He's the Tomas Berl Professor of Medicine and was the Chief of Renal Division and Hypertension at the University of Colorado until recently. His research, which has been funded by the National Institutes of Health, has focused on the role of sugar and especially fructose in driving obesity, diabetes, high blood pressure, and kidney disease. Much of this work has explored the role of fructose metabolism, especially the generation of uric acid in driving this phenotype. And his work has included studies ranging from molecular biology, integrative physiology, and evolutionary biology. He's the author of 3 books, The Sugar Fix, The Fat Switch, and his new book is called Nature Wants Us to Be Fat: The Surprising Science Behind Why We Gain Weight, and more importantly, how we can prevent and reverse it. There's a new scientific breakthrough that Rick discusses in this book, and we'll get into very shortly. So with that said, Rick, welcome back to the Anti-Aging Hacks podcast.
Thank you, Faraz. It's really great to be back.
I love having these conversations with you because, like I was telling you before we started, any question I ask you, you have a study to answer that question. And I'm going, how does he have all these studies under his belt? But you do, which I love.
So, been around a long time for us.
Well, you don't look old, sir. You're still a youngin'.
Thank you.
In my book. Okay, so you were on the show a few months ago, Rick, and we had a fantastic interview about fructose and a little bit of uric acid and what it's doing in the body. What's changed and what's new in your world since then?
Since then, well, we are getting close to putting out our paper showing that alcohol actually activates the fructose pathway, and that alcoholism and fructose metabolism are closely related. And so I don't know if you want me to take you through that now or...
No, let's wait. But yeah. That's a great segue for later on.
Okay,
fantastic. So Rick, real quick, I know that listeners have heard of you before, but I'd like for you to do a light intro into who you are and how you got into kidney and then fructose and then writing these books.
Yeah. Well, originally I wanted to be an anthropologist when I was in college, and I actually majored in archaeology. And that may be one reason I like evolutionary biology. But I ended up going into medicine at the encouragement of my father, who was in academic medicine. And I ended up becoming a kidney specialist, and I loved clinical medicine. I still do clinical medicine, but I also fell in love with research. And I became very interested in what caused kidney disease, and kidney disease is very much linked with high blood pressure. And so I became interested in what causes high blood pressure. And that made me get interested in what causes the metabolic syndrome, this constellation of signs where you get obesity and metabolics and high blood pressure. And in that process, I discovered, I wasn't the only one that discovered this, but I realized that sugar was very important in this pathway. And as we studied the sugar, we had this surprising discovery that sugar, and particularly fructose, which is in sugar, produces uric acid. And it produces uric acid through a non-caloric pathway. It doesn't involve the calories. It's a kind of an offshoot. And when we found that uric acid was involved, we suddenly realized that, sugar was likely stimulating and driving obesity through a pathway that didn't involve its calories. And everything was about calories back in those days. So it was kind of a really exciting discovery. And that's how I got into it. And then for the last 20 years, I've been studying this.
That's fantastic. And I'm thankful for you to be sharing all of your knowledge in simple bite-sized chunks that normal people can actually follow and take advantage of. So about the book, Rick, you wrote this new book, which is obviously got a scientific breakthrough that I want to touch on. And you opened the book by talking about what's really happening in society in terms of obesity, in terms of diabetes, pre-diabetes, cancers, Alzheimer's. Can you touch on, from your vantage point, how bad is it getting and how long has it been going this way?
Yeah, so, history is a wonderful tool to try to, look at trends. And, around 1900 or in the 1800s, let's just say 1900, obesity was really rare. There was a study in Civil War veterans, that showed that obesity was present in only about 3% of the population in the 1890s in the U.S. And today it's over 30, 40%, and approaching 50%, as you had mentioned earlier to me before the talk. And high blood pressure was extremely rare in 1900. It was like less than 5% of the population. Diabetes was super rare. And Sir William Osler, who wrote one of the main books on medicine, pointed out that there were only 2 to 3 cases of diabetes per 100,000 population.
Wow.
Now there's some countries where diabetes can make up 25 to 30% of the population. Mm-hmm. And even kidney disease, chronic kidney disease was much less common. Heart disease was super less common. And in fact, most of the heart disease around 1900 was from rheumatic fever and was valvular disease. And actual myocardial infarction or heart attacks were thought to be extremely rare. And angina, which is the chest pain you get with impaired blood flow to the heart, that was, this kind of strangling chest pain. It was thought to be, extremely rare. And not until about 1930 was it being seen regularly by family practitioners. But that all changed because during the 1900s, there was this kind of stepwise increase in all of these diseases. And also we started recognizing Alzheimer's as a disease that, it was always around, but particularly dementia occurring in people that were younger, like in their 60s and so forth. That started to really significantly increase, and many, many other things, cancers and so forth, a lot of them increased. And now today, these diseases are so common that when you're an internist and you are working in the hospital, so many patients have combinations of this, obese, diabetic, heart failure, and they're all. It looks like they all rose around the same time, and are potentially and epidemiologically linked to each other. And one of the striking findings of the book is that many of these diseases are probably all linked to one major pathway. And we talk about that pathway in the book.
Wow. Well, we can't wait to get in. And before we get in, Rick, I know we're going to talk about sugars. We're going to talk about fructose, high fructose corn syrup. So I know we've done this before, but if you would take 1 minute just to define these 4 terms, glucose, fructose, sucrose, and high fructose corn syrup, that'd be great.
Yeah, it's really important because it's confusing, right? I mean, you hear all these names and what is what. So when we talk about sugar, most people think about sugar as table sugar, the white granulated sugar we talk about. And that is actually is called sucrose. That's its official name, sucrose. And sucrose is really 2 sugars connected to each other. They're bound to each other. And one is glucose and one is fructose. And fructose is the sugar in fruit, why you like fruit, it's got fructose in it. And glucose is that main sugar that's in our body. It's the main carbohydrate that our body likes to use. And so we have we have glucose levels that we monitor, and if the glucose levels go up too high, it's diabetes. And if the glucose is too low, you get hypoglycemic and lightheaded. So glucose is kind of the main fuel, and all the biologists have focused on glucose. And it's, this is really the main sugar that people have studied. And there's been much less research done on fructose because fructose blood levels are pretty low on us. We do have fructose blood levels, but they're like 50 to 100-fold lower, or maybe 10 to 50-fold. And so fructose is also in sugar. So sucrose, or table sugar, has fructose and glucose bound together, half and half. Then there is high fructose corn syrup, and this was, is derived from corn, like the name, and it's a liquid syrup, and it's very easy to mix into foods, and it doesn't crystallize so much. And so it gets added to lots of foods because a little bit of sweetness really makes food taste better, and for a lot of people at least. And so it's added to things that you can't even imagine, like crackers and meats even. And I mean, and high fructose corn syrup is really a mixture of fructose and glucose, just like sucrose, but they're not bound together, so you can change the proportion. And so they found that if the fructose is a little bit higher than the glucose, like 55, 45, that people like that taste a little bit more than even sucrose. And so often, like soft drinks and stuff, they put high fructose corn syrup and it's like 55, 45. And they're even making it more, like in some fountain drinks, they're making it 65% fructose, 35% glucose. So the high fructose corn syrup allows them to mix it up a little bit, okay?
Yeah.
And those are your two main added sugars.
These billion-dollar companies just need to sell food. They need to sell their products. They're doing whatever it takes to get the population to be hugged at whatever cost.
Yeah, absolutely.
It's a travesty of what's going on. So, Rick, I guess let's get into the gist of the book. Like you've said, diets don't work, or we know diets don't work. That's normal information. Everybody knows this. You follow a diet for a few months, and then lo and behold, 6 months later, you're back to your original weight. Obesity persists. Even radical steps, in my experience and talking to people with bariatric surgery that have had that, it's like 90% remission after a year and a half of physically losing a ton of weight. You gain back that original weight that you had before you went in under bariatric surgery. And you've looked all over. You've looked at the Ice Age. You've looked at hibernating animals to look for answers. So why does nature want us to be fat, Rick?
Well, it's very, very basic in biology. And that's the importance of survival. Everything's about survival. And one of the key things for survival is you have to have enough nutrients to keep you going. You have to have the calories, and you need the calories for the brain in particular, because if your brain's not functioning, you're a dead duck. Mm-hmm. So what happened is, when animals start starving, they actually activate an alarm signal. So it's interesting. We have, we store fat. Everybody has some fat, and we also store carbohydrates. And in plants, stored carbohydrates are called starch, but in people, it's called glycogen. So we have these stores. So if we don't eat, we can survive off our fat, and we can survive off our glycogen. And animals, will become fat when they know that there's a period of time where there's going to be no food. Like a hibernating animal will gain weight in the fall, and then it will not eat throughout the winter and live off its fat and live off its glycogen. And what they've shown is that when you're living off the fat, animals will actually stay calm. When they go into this mode, they actually are calm, and it's not really a crisis because they've got calories. But when the fat stores get low, what happens is there's an alarm signal, and the animal, like if it's an emperor penguin, for example, an emperor penguin will get really fat before it nests because it has to sit on its nest out there in Antarctic for, it's out there for maybe a couple months. And during that time, it's burning off its fat. And it's fine while it's sitting on the, nesting with the egg because it's got all that fat. But it runs out of the fat, it's an alarm signal. And it will actually have to leave the egg and forage and start foraging for food. And it's like a danger signal. And if it doesn't find food, it will die. So animals don't want to go through that stage of starvation and then, have to find food or die. So what they've done is, or what nature has done, is it's developed a mechanism to kind of turn on a survival pathway with the goal of doing it before you're in trouble. Before you're in trouble. Like the animal, as winter is approaching, it will suddenly, it will be its normal weight going through the summer, and then suddenly, in a period of just a few days, it will dramatically increase its food intake. Instead of maintaining a normal food intake and keeping a normal fat percentage, suddenly it will just start looking for food. And it's like it's hungry all the time, and it eats all these foods and fruits and all the things it can get to store the fat. And during that time, it actually activates all these survival pathways, like it becomes insulin resistant. You say, well, insulin resistance, that's bad, isn't it? That's what leads to diabetes. But actually, if you're starving, insulin resistance is great, because what it does, I mentioned that glucose is the main carbohydrate we like to make energy from. Well, when you become insulin resistant, the skeletal muscle becomes resistant to insulin. And insulin is the hormone that moves glucose into the cells so that you can metabolize it. So when the muscles get resistant to insulin, they get less of the glucose than they normally would. They will get it, but they get it less. And what happens is when the muscle can't get enough glucose, the blood glucose levels go up. And there's more glucose around because the muscle normally uses so much of the glucose. And so what happens is there's more glucose for the brain, and most of the brain does not need insulin in order to take it up. So it's great for the brain, because if you become insulin resistant, you are definitely getting more of your share of glucose than the rest of the body. And that's important if you want to survive, because if there's not a lot of food around, you want the fuel to go to the brain. So it turns out that things like the blood pressure goes up. When you're starving, you need to have a strong circulation. You need to be able to stand erect even though you don't have a lot of food, and you need to be able to go out there. And another thing that happens is you start foraging, and these animals will start foraging. You need to be really good at finding food. And you know what that means? It means short attention span. You need to be able to go in, look around, see everything really quick, and make decisions quickly, because you don't have a lot of time. And you can't deliberate. And you have to be able to, you have to be a little bit of novelty seeking, a little exploratory, because you may have to go into areas where you've never been before, and there may be predators, but you have to be brave. You have to be a little aggressive, because you have to find the food. And so all these things happen with these animals in the fall. They trigger this process where they forage. And here's another thing they do. They reduce their metabolism even before they hibernate. So they try to burn less energy. But they don't want to be burning less energy while they're foraging, because they need to forage. Mm-hmm. So they burn their they reduce their resting energy. So when they're foraging, they still have the metabolism, but then when they get back, they kind of drop to a lower level of metabolism so that they can conserve energy. So it's a brilliant system. It's an absolutely brilliant system. They even reduce their oxygen needs because they shift their mitochondrial function. The mitochondria is what makes our energy, and it makes up most of our energy, and mitochondria is so important for us. But if you're starving, you don't want to use all that energy with the mitochondria, because it has to consume, it uses oxygen to produce the energy. And what if there's not enough oxygen around? So what they do, that's another survival thing. How do you protect yourself? Well, you reduce the amount of metabolism by those mitochondria, and you shift to glycolysis, which is another form of it's a more primitive form for making energy, and it doesn't require oxygen. Mm-hmm. It turns out that cancer cells like that because they don't live they often live in a low oxygen environment. But if you're in a situation where it's dangerous and there's not a lot of oxygen around, you want to suppress your mitochondrial function. You want to reduce your oxygen needs. And there's an animal called the naked mole rat. And this guy lives in Africa, and he burrows deep into the ground in these little holes, burrows, where there's very little oxygen present. And they've shown that, when you put a rat down there, it can't live in that low oxygen, or a mouse. It just lives like 1/20th the time of a naked mole rat. They are professional at living under low oxygen conditions. And interesting, they activate this survival pathway. Mm. So I became very interested in saying, oh my God, there's this survival pathway, and it's really the metabolic syndrome, the insulin resistance, storing fat, storing carbohydrates, raising your blood pressure. These are all things animals want to do to survive. It is something nature wants. It's like an instinct, and animals will do the same thing if they're going to fly long distances. They prepare before they fly, get that fat on, and it's like a good thing for them. And so for humans, what's happened is, if we go into our past, we were using this survival switch too to try to help us through tough times. But now we know we're actually eating foods and so forth that activate this switch because we've learned to love those foods, and we've developed tastes for foods that seem to do this. And it was all to help us survive. But now we're so good, and with all the industry and agricultural and being able to ship foods all over the world, we can get whatever we want. The average grocery store has like 80,000 different types of food. Yeah. I mean, and so now we're set up. We can eat all we want. So we're activating the switch chronically.
Okay, got it. So in terms of the explanation, Rick, thank you for sharing. That's such a key explanation. I think humans have forgotten how brutally hard it is to live in nature. Just imagine not having the homes, air conditioning, heaters, cars that we have. Just spend 6 hours out on a cold day, and you're not going to be a happy person. And so these animals have to brave these conditions of ice and snow for months and months on end, and no fruit growing or foods growing anywhere on trees, and predators on the lookout for them. So that's why nature is turning on this metabolism so they could hide and stay put somewhere in a little burrow or a corner for months on end, as much as possible, while they're not foraging, and still survive the winter. So it's so key. And I think we forget, and we just eat all the time, and we take food for granted. And like you said, we'll get into types of food and what those are doing to us. So I think that's very important. Now, one question on that, Rick, do we know what turns on suddenly in a few days when the animal starts eating too much? Is there a hormone? Is there a changing weather pattern? Is there something that tells the animal that start eating?
Yeah, that's a great question. It's really been a major question, that has, been discussed and studied for a long time. And our group kind of stumbled on what we think is the answer. We're pretty sure it's the answer. Mm-hmm. And that is that in the fall, it turns out that it has to be something that's really powerful at activating the switch. You've got to have something that really, it's a pretty impressive change. And, we found out from studies in animals that if we gave them sugar, and especially in the drinking water, if they drank sugar, this suddenly happens where they start eating more. They get hungry. They get thirsty. They start storing fat. They start storing glycogen. they become insulin resistant. They drop their oxygen needs. They drop their resting metabolism. And all the different processes associated with this switch can be absolutely done by giving them sugar or sucrose. And you can do the same thing with high fructose corn syrup. In fact, it's maybe even faster. It is faster. And then you can also do it with fructose. And so if we put fructose in the drinking water, they do it. And so this got us recognizing that fructose was very likely involved. And when we started looking at what happens in nature, we found that, like bears will suddenly, in the fall, with the first frost, the fruit starts to get sweeter. It actually causes the fruits to sweeten a little bit. And it seems to like trigger these animals to start eating it. And as they eat more and more, they start eating voraciously. And, bears can eat 10,000 grapes in one day. Wow. And, actually, you start seeing so many examples in nature. I go through a lot of them in the book. But fish will eat fruit, and insects. And I mean, there's a lot of this kind of fat storage that is going on that seems to be triggered by eating sugar and fruit, honey, and so forth. So that's for sure. And so we realized that fructose was our first thing, was to look at fructose. And we even did studies where we studied animals that couldn't taste sugar, but we found that they still loved sugar. And it's because that sugar, once you metabolize it triggers this hunger and foraging and desire to eat more. So you don't even have to taste sugar to become addicted to it, but the taste actually encourages you to eat more. And so then we started trying to understand how the fructose was working and why it was different from all the other foods.
Yeah, and that's a great segue. Like, what is happening with the metabolism of fructose once it hits the liver? I assume it's all happening in the liver, right?
Yeah, it's mainly in the liver. In the book, for sure, we focus on the liver because we did experiments that really showed the key role for the liver. But I think that there is some evidence that the fructose is also working in the brain and in the vasculature and in the kidney. But so there is some effects elsewhere that I don't really get into too much in the book. But certainly the liver is the main guy.
Can you talk about, Rick, how it's different from glucose metabolism, the fructose, and if there's different pathways things are going down?
Yeah. So normally think about food as a source of energy. So we get our energy that we do everything from the food we eat. And when we eat food, the calories in the food is usually how we measure how much energy we're getting. And when you eat food, it generates energy in the form of a substance called ATP. So they sometimes call it the currency of the body for energy. So you make ATP, and then we burn the ATP when we're active. So we're burning it when we're walking. We're burning it when we're thinking. We're burning it all the time. Even when we're sleeping, we're burning energy. We need energy to live. Okay. So the food provides the energy. If we don't get the energy from the food, we get it from our fat and things like that. Because when fat breaks down, it produces energy. When glycogen breaks down and you metabolize it, you make energy. So everything's about making energy. Energy is the key thing that we want. We want to have plenty of energy in our cell. So what happens, though, is that the process of metabolizing and digesting food and then metabolizing food requires energy. So you use energy during digestion, and you use energy in the liver when you're breaking down the glucose molecule, for example, to water and carbon dioxide. In that process, we do spend some energy, but in return, we make more energy. So it's a good way to win. You spend a little energy, you make a lot of energy. Yeah, and that's how we get our energy from food. So almost every food we eat, makes energy. and we end up with a higher energy level than when we began. Fructose also produces energy, but it tends to drop. The overall energy in the cell drops. So even though fructose is generating some energy, when we're done, the total energy fall is lower in the cell, and that's because there's more energy being consumed, and the energy level, even more importantly, gets reset to a lower energy in the cell. So the body normally has energy filling up the tub, and when you eat fructose, it drops that energy by about 20% or so.
Mm-hmm.
And there's still plenty of energy to function, but it's kind of, we went into a low fuel state. The gas light went on. It's time to go to the pump. And that going to the pump is actually activating the switch. It's time for us to start to eat more and to put on more fat. And we're going to start foraging, and we're going to raise our blood pressure. And we're going to do all these, we're going to become insulin resistant because it's an alarm signal. The low energy is an alarm signal. And what's tricky, what's sneaky about fructose is that, when you're starving, you really, that energy falls and the signal goes on, you're going to die if you don't get it. But here you could actually have on board. But what happens is this fructose turns off the ability to burn the fat. Mm-hmm. So it tricks you into thinking that you're starving. And the idea is it wants you to store more fat. It's a process to say, oh, look, we're going to prepare for the disaster. So we're going to put on more fat in preparation for the disaster. And that's what fructose is doing, because it's dropping the energy in the cell independently of your fat stores. You can be really overweight and have a ton of fat, and you eat fructose, and the body's hearing, I don't have enough energy. And the way it does it, it's a biochemical pathway. So, you have to actually use some ATP to metabolize glucose and some ATP to metabolize fructose. They start off fairly similar, mm-hmm. and they're both 6 carbon molecules. They look quite similar. And yet what happens is when glucose has a protection system. So when it's using the energy to metabolize it, there's a system that turns off the reaction if the ATP levels start to fall. So as they start to fall, the whole reaction is stopped. And then when the energy is good again, you can metabolize it. And this way the energy never falls. No, I mean, it falls just so little,
right.
Mm-hmm. But with fructose, there is no backup system. There's nothing to say stop. So it's really dependent on the amount of fructose and also the concentration. It's really the concentration that drops it. So if you drink a soft drink like really fast, the concentrations, first off, there's a lot of fructose in a soft drink, and secondly, you get it fast. So it's like a high concentration. Mm-hmm. If you took that soft drink and you sipped just one little sip and waited 10 minutes and one little sip, the concentration of the fructose will never be high enough to trigger that fall in energy. Mm. But it's the fall in energy that does it. So once the energy falls, then there's a whole cascade of reactions. And I don't know if people want to hear about these names of these enzymes, but basically the ATP gets broken down. And normally it gets broken down to ADP and AMP, and then it's made back into ATP. It's a little cycle. Mm-hmm. But with fructose, when it breaks down to AMP, the AMP is swept away. It's like swept out of the system through a pathway that makes uric acid. So when it's making the uric acid, the AMP is going that way instead of going back to make more ATP. And so it keeps the ATP levels low. Mm-hmm. And then the uric acid goes into the mitochondria and stuns the mitochondria to reduce the amount of ATP it's producing. And it also blocks an enzyme that gets activated in starvation to bring up ATP levels. It's called AMP activated protein kinase, and it knocks that down. And so there's this ingenious system. It's ingenious. It's like brilliant. Nature is brilliant, and so it drops the energy and it finds a way to kind of keep that energy low. And what that does is it immediately makes you hungry. Just that process alone, which when you drop the energy in the liver, which is the main site, animals get hungry. So there's an immediate reaction, I want to eat. And then over the long term, it induces you to become hungry by making you resistant to this hormone leptin. And so then you want to eat more too. So you got all these mechanisms going in. There are probably other mechanisms too, but basically you get hungry and you want to forage and you activate what I call a switch. It's not a on-off because you can kind of dial it up or dial it down. So it's more like a dimmer switch, but you can move it. If you drink a lot of sugar right away, boom, it's going to go way over. But you can take it up a little bit or take it back a little bit.
That's so fascinating. And you tied it right back to what happens in nature with these animals. As it's turning to fall, all the fruits are getting sweeter and sweeter and sweeter. And so they have no choice but to activate the survival pathway. It's being done for them or to them by the fruit that they're eating. And for humans, unfortunately, we're doing it through eating high fructose corn syrup or fructose. And we'll talk about glucose in a bit too. But once this gets turned on, then, like you said, the cell goes into a low energy state, and then the AMP gets shuttled out of the cell, and then AMPK gets shut down. It creates uric acid, and uric acid harms the mitochondria, which tells it to reduce the energy it's producing. So that's a double whammy. This is all bad news, right?
It's bad news.
It's just
good if you're trying to survive.
Right. It's bad news all around because now you're just eating more and eating more. And I assume that when you're eating more as humans, we will go eat more food, which means we will eat more fructose or a lot of glucose that will turn this on again. And so now we're in this state for a long, long time. Is that correct?
Yeah. And what's more, that a constant attack on the mitochondria, initially it's completely reversible, but over time the mitochondria actually will become smaller and less effective, and eventually you start seeing a decrease in mitochondria. And that really makes it difficult to lose weight and keep it off because you kind of reset your balance to kind of a lower energy state, and your body reflects that by staying overweight. And so for those people interested in aging, I know you are, this process can be involved in the aging process. And so, this is another consequence of having the switch on for forever. There's you probably know, I know you know about this story, but that if you take animals and you calorically restrict them, they can live longer, right? And everyone knows that. And that the deal is you bring them down to 70% or so of what they normally eat, and they have like no body fat. And so they actually do well. And I personally believe that the reason is because there's less oxidative stress that occurs with eating, to the mitochondria. And this oxidative stress is how the uric acid injures the mitochondria. And it's part of the consequence of trying to store fat. When you want to store fat, you're kind of doing a little bit of oxidative stress to this really important energy factory. And over time, that can cause a loss of the mitochondria. And you really want to have, if you want to live a long time, you want to have really good mitochondria. So if you put animals on 70%, they have less mitochondrial injury, they live longer, but they have no body fat. Right. And so they're dependent on you giving them food every day. But if you put those animals that live longer in the laboratory, if you put them out in the wild, I predict that they would die very quickly because the first calamity that hits them, the first 2 weeks of of some blizzard or something where they can't get any food, they have no energy stores. Right. So nature wants, nature understands, if nature can think, this is another, but if nature and evolution developed in such a way to help maintain survival of animals, and those animals that could store fat were the ones that tended to survive. But if you store too much fat, your predator is going to get you. So they normally store a certain amount, and then when they need to, they can trigger this switch to gain fat.
This is so cool, Rick. I was just going to ask you about this exact question is as you're gaining weight, as you're eating excess calories or eating too much fructose to activate this pathway where uric acid gets turned on, and uric acid is harming your mitochondria long term. So the process of gaining fat is actually damaging the mitochondria. So let's say that you wanted to be a certain weight, and this is a tricky question for you. Let's say you wanted to be 10 pounds overweight, right? It's best to gain those 10 pounds very, very quickly, not over like 5-year period of time, because you're just damaging the mitochondria over long term. Once you get to that 10-pound overweight, then you can maintain homeostasis and your mitochondria are going to be okay, right?
Yeah, absolutely. So there are even studies that show that when you first get overweight, like if you're young and you're 20 years old and you've recently gained weight, and actually almost everybody when they're in their teens or in 20s, if they're overweight or obese, they still have pretty good mitochondrial function. It takes a long time to really knock it down. I mean, obviously there's genetics and other factors, so some people will knock it down faster than others. But basically, it's a truism that when you're overweight, you've only been overweight for a few years, or particularly if you're young and overweight, it's relatively easy to cure the obesity. And you can put them on a diet, and they'll lose, and almost any diet will work for losing weight. But the key thing is if they stay off sugar and so forth, it's much easier to get back to your normal weight. Mm-hmm. But if you've been overweight for a long time, obese for a long time, then dieting becomes, you've lost mitochondria and you kind of get locked into that new weight. And then what happens is when you diet, you lose. It's actually, you can lose weight, but it's a little harder. But you can still do it. But it's very hard to keep the weight low unless there's ways to really boost those mitochondria.
Mm-hmm. Okay.
And so. Yeah.
Okay. I have a few more questions about how we start reversing and outfoxing nature, as you've said. But before we get to that, one last point I wanted to ask you about, Rick, is the leptin hormone that you've talked about in the book, where people that are overweight just get desensitized to leptin. Talk about how that works and the pathway to the brain and why that's important.
Yeah, so there are many hormones that regulate weight, as you know, and some of them we have not studied. So like GLP-1 we have not studied, and I'm sure it's involved. But one of the breakthroughs in obesity research was the discovery of a hormone called leptin by Friedman. And what happens is that the fat itself can make a hormone. And this hormone's called leptin, and it goes up to the brain where it signals to the brain a sense of fullness. And what's interesting about it is, this pathway is blocked in most people who are overweight. So if you're overweight or obese, we often have high leptin levels in our blood, but it's not working to tell us that we're full. And so we keep eating. And you can test for leptin resistance, like in an animal, by injecting leptin, actually injecting the hormone into the animal. And if you inject the hormone to the animal, it will reduce its food intake over the next 24 hours. So like if it's eating, standard 10 grams a day of chow, and you inject it with leptin, it will drop from 10 to 6 grams. It will still eat some, but basically it will reduce its intake. And if it's leptin resistant, because the brain isn't responding to the leptin, and the problem is at the brain level, but if you give them an injection of leptin, what happens is they continue to eat the 10 grams a day. And so this is how we could test it in our animal models. And what we found is that when we gave sugar, that food intake goes up initially probably because of this ATP dropping in the liver. That in itself just stimulates hunger. But over time, there's a more powerful system that stimulates food intake, and that is the development of leptin resistance. And it's a resistance that occurs in the brain in the in a part called the hypothalamus, and you can show it, and you can demonstrate it by giving these animals leptin, and they keep eating. And we think that the leptin resistance is playing a big role in why animals eat more. And so when you turn on the switch, they eat more food than they normally do. But what's kind of cool is you can do a thing called pair feeding, where you give sugar to an animal and they eat more, and then you say, okay, but I want to know, will they still get sick if I prevent them from eating more? And so you pair feed them, so you give them the same amount of food as the control group, and that way they can't eat more food. They're all eating the same amount. And when you do that, you can really have a significant effect on weight gain, because a lot of the weight gain is from that extra calories. But when you give the same calories, they still put on fat, the animals given sugar. And they get fatty liver, they get insulin resistant, their blood pressure goes up. So a lot of the switch still occurs independently of the food intake. So this idea that it's just a calorie is not true.
Right.
It's making you hungry, so you eat more. And even when you control what you eat, there's still effects of this fructose on your body.
Okay. I will rephrase or paraphrase something I read in the book, Rick.
Yeah.
It says that all weight gain is caused by an excess of calories, but fructose activates a biological process that makes you persistently hungry, drives you to eat more, and turns on metabolic syndrome, right? That is why high-fat diets can work, because if you don't have fructose, then you can eat the high-fat diet. It's not a problem. But if you have fructose in there, then you gain a lot of weight.
Right, exactly. So that's why if you go on a low-carb diet and you're eating a ton of fat, and the fat's 9 calories per gram, whereas it's 4 calories per gram for carbohydrates, you won't get fat on a high-fat diet alone, because you're not leptin resistant. And we actually did those experiments where we
of course you did.
I'm sorry. I will say that fats are slightly different. Butter fat seems to cause a little bit of weight gain on its own, but most fats don't. And so you need that fructose. Yeah. The other thing, though, is that, the weight gain is from eating more, for sure. But if you control the food intake, but you went out for a very long time, like a year or 2 years, then the lower metabolism of the switch will also cause the weight to slowly increase a little bit. And it may amount to a pound or so a year. But if you're gaining a lot of weight, it's probably more from the food intake than it is from the reduction in metabolism, in the short term at least.
I gotcha. Interesting. So you've got to find a way to break this chain, this evil chain of high fructose, which I think you've explained on the podcast before. High fructose is created by just eating a lot of fructose. You can also have a lot of glucose or high carbohydrate, right? You could have a lot of salt. You could have umami. You could have dehydration. All of this turns on fructose, correct?
Yeah, actually, we haven't really talked about on this in this interview, but yes, the other big discovery we had, besides the fact that fructose could activate the switch, was that you don't actually need to eat fructose to your body can make fructose. And it was really a disappointing discovery, because I was just hoping it was sugar and fructose, but it isn't just sugar and fructose. The body will make fructose from a number of foods, just as you said. So the big ones are high glycemic carbs, potatoes and rice. In the animals, for sure, we can show that these can actually turn on a process in which fructose is made, and then the fructose that is made is actually what's responsible for turning on the switch. So it's scary. All roads lead to Rome, as they say. It seems like this is one pathway, and there's different ways to activate it.
And if I'm a person that's listening to this show that's maybe 10, 20, 30 pounds overweight and is trying to lose the weight, at this point I'm going, can you give me a break? Like, come on, give me something I can work with, which is what we're going to get to, actually. So Rick's got, in his book, he's outlined a lot of ways you can break free and outfox nature, as he calls it. So, Rick, if there's not anything more you need to add to the fructose conversation, I'd like to know about some practical tips we can use to start to get out of this vicious cycle.
Yeah, so I mean, the very first thing is you want to try to reduce the activation of the switch. Remember, it's a dimmer more than it is on or off. So you can gain a lot just by kind of pushing the needle. You don't have to turn it off fully. I mean, if you turn it off fully, it's great. So like if you go on a keto diet, that will remove the high glycemic carbs, and it will remove a lot of the fructose all at once, and it's a very powerful, it's a good way to start. And if you can stay on a keto diet, the more power to you, because it is very effective. But there are other ways. A low-carb diet will help, right? And so reducing sugary liquids. Liquid seems to be because when you drink a liquid, it gets absorbed much faster because you don't have the fiber of food and all that kind of stuff. So liquid sugar is really bad. Highly concentrated sugar is really bad. Now, it turns out that small amounts of sugar, like 4 grams in a fruit, or 6 grams, isn't nearly as bad. And there's a trick to it. Not only is it a smaller amount, and not only do you have fiber and things like that, and not only are there things like vitamin C and other things in the fruit that help fight it, but there's also an intestinal shield. We call it an intestinal shield. What happens is the intestine will metabolize a very small amount of fructose like a calorie. So if small amounts of fructose, like in vegetables, like in many vegetables, is not going to cause a problem because the intestine's going to metabolize it in a safe way, and so it's really eating a fair amount of fructose that really triggers it. So a single natural fruit, it's true. Like some fruits are very high in sugar, like apple might have 8 to 10 grams. So that could theoretically activate the switch if you ate it really fast. And apple juice is really, it's like drinking a soft drink because it's got so rich in sugar and fructose. But so one option is reduce sugary foods, and particularly rich sugary foods. But there's a lot of vegetables that are really healthy, lettuce and vegetables. There's a lot of proteins that that are not so rich in umami, and things like chicken and things like fish. They're very good, and a lot of the things like in the Mediterranean diet and the paleo diet are fairly good. And if you do eat bread, you have to eat very little and have to be very careful. Or some people will like put avocado on it. And when you do that, the glucose doesn't go up as high. And when you eat high glycemic carbs like rice or potatoes, it's the reason they turn on fructose is by increasing the glucose in the liver and the blood. So if you could eat those slow, or if you could mix it up with things that can reduce the glycemic index effects, like putting avocado on a piece of bread, for example, can blunt the glucose response. That would probably work. And then there's lots of other things I talk about in the book. Vitamin C, for example, can help neutralize some of the effects. And then you got to do things to help the mitochondria. So you want to block the injury, you want to block the activation, but you also want to stimulate recovery. I mean, you got to do both things if you want to get your energy and youth back. And so you have to do things to stimulate your mitochondria. And the best thing is exercise, but it's a certain kind of exercise. And you don't want to do super strenuous exercise, but you want to kind of what we call zone 2 exercise, where you're kind of walking at a fast pace or jogging at a slow pace, where you're not fully short of breath, but you're able to continue it for like an hour or 45 minutes. It seems to take about that much time to stimulate those mitochondria. So that's a lot of what I mean. There's a lot more detail, and I hope that you get interested enough to look at the book. But this kind of gives the grand view.
Yeah, this is fantastic, Rick. I've been reading the book, and of course, I looked at all the ways we can outfox this, and I'm super interested in doing this. But also, since I had you on my show last, I've started to change some lifestyle habits. Right, I was looking at, I don't eat bad at all, and I don't do not eat
Yeah.
processed food. But I was looking at the sugars in an apple and a pear, and I was thinking maybe I shouldn't eat an apple and a pear together. Maybe I should
Right.
spread them out, and maybe I
Yeah.
shouldn't eat them in a shake, like blend them in a shake.
Yep.
Maybe I should eat them solid because
Yeah.
it will take longer for it to get into my bloodstream as opposed
Yep.
to just a shake where it goes right in. So again, these are simple things, and Rick's listed a lot of these that can have long-term effects on your health if you just understood. And I'll say one more little story anecdote that I had. And Rick and I are both fans of putting on continuous glucose monitors
Right.
on our arms, because that tells you, as you're starting this journey of health, you can look at your daily food or your diet as you eat it today, and you can start to measure your spikes in blood glucose after every meal or after every bag of chips, whatever you're eating, right? And so you can start to see real time what's happening. And as you make changes, these things will start to come down, the numbers will. And for example, one time, once in a while, I reward myself, Rick, with a coffee from Starbucks, and
Yeah.
I'll get some additional sweeteners or whatnot, like a hazelnut. It's not even a
Yeah.
sweetener, but a hazelnut
Yeah.
in an Americano. And that like boosted or shot up my blood glucose by 40 or 50 points. And I was like, what? I'm never
Exactly.
doing that again, right? That's a stupid drink. So it's a course correction, and it gets you to live a long and healthier life for the rest of your life. Uh,
Yeah.
and so Rick's got a lot of these tips in there as well. Go
Yeah,
ahead,
I
Rick.
do believe in the continuous glucose monitor. I think it can really help. And so you're totally right. And it's surprising. Everybody's a little different. So it's really good to see how you react when you get that hazelnut Starbucks or whatever. Because some people will react less and some will react more. And it's just your genetics and other things that's going on.
Last tip about alcohol, Rick. What's your take on it?
Well, what we've discovered, and it's not yet published, but it's under review, is that alcohol also can turn on fructose production in the body, and that when you block fructose production, you can affect the craving of alcohol. And so the craving of alcohol and alcohol effects like the beer belly and things like that have a relationship to this pathway as well.
Mm-hmm. Fantastic, folks. The book is called Nature Wants Us to Be Fat, and it's a fantastic read. It's not a very long book, but there's plenty of good anecdotes, stories like going back to the Ice Age and talking about primates and all that stuff that's in there. And it's a fascinating book. So I would highly encourage you, if you're interested in health and wellness and living a long life, to get this book. It's going to be out very soon after the release of this podcast. So, Rick, with that said, thank you very much for coming on the show again.
Thank you very much. It was a true delight.